So we're going to do a bit of revision of functions. Remembering that a function is anything to 1. I'll just write that down. Anything to 1, and you've got yourself a function. So I've drawn a few functions up here or relations that we'll talk about, and we'll determine if some of them are functions or not. If you're given a graph, then you should use your vertical line test to determine if something is a function, and your horizontal line test to determine if it's a many-to-one or one-to-one function. So with this one here, the vertical line test can only ever go through at most once. Right? Going vertically, we can only get through at most once, which means that it's to 1. The vertical line test tells it what it is to, what the second number in that representation is. The horizontal line test tells us the first thing here. We can only ever at most go through once, so the horizontal line test is passed, and it's telling us this is 1 as well. So if you pass both the vertical and the horizontal line test, it's a 1-to-1 function. Now, here's another example of a 1-to-1 function, but written in terms of a mapping, where each one goes to 1, each one goes to 1, and that's straightforward, a 1-to-1 function here. And sometimes you're given a collection of points, such as these points that are written here out to 0, 1. And you can see that there's no repetition. The first numbers that are given only ever go to the same second number, and the second numbers that are given only ever come or go back to the same first number. So all of them are unique pairs as such. So that's an example of a 1-to-1. Now, if we move along a little bit, we could talk here about the graph of y equals x squared. Once again, I can determine if it's a function or not straight away by the vertical line test. So it passes the vertical line test, so that means it's to 1. It's a function. Anything to 1 is a function. What about the horizontal line test? Well, there's one point that passes it, but look, you can find a way that it fails, because at some point it's gone through more than once, it's gone through the graph, then it's failed the horizontal line test. If it's failed the horizontal line test, then it's many. A failure means it's many, a pass means it's 1 in this context. So that's a many-to-1. Now, it is a function. So these first two relations that I talked about are both functions because they're to 1. And if we can look here and see that many of these guys are going to one of these guys. So it's a many-to-1. And here, when we look at this collection of points, pi on 6 goes to a half, but also 5 pi on 6 goes to a half. Pi on 4 goes to 1 on root 2, but so does 3 pi on 4. And pi goes to 0, and so does 0 go to 0. So many are going to 1. So it's a many to 1. The next type that we look at might be given by a graph like y squared equals x, for example. Now, it passes the vertical line test? Not. It doesn't, right? If it doesn't, then it's too many. It doesn't pass the vertical line test. And the horizontal line test, yep, it passes it. So it's 1. 1 to many is that one. I don't know why that's on there. This here, we've got 1 going out to many different ones. This one's going to 3 different ones. So it's 1 to many, if you're mapping from left to right. And here, our 1 goes to root 7, but also minus root 7. Our 2 goes to root 15, but also minus root 15. So that's one x value going to many y values. Finally, if we look at the vertical line test here, fail. If we look at the horizontal line test, fail. So if you fail that, it's many. If you fail this, it's many. So this is a many to many. You can see that represented in this way too. Both of those guys are going to this one. So it's like many are going to 1, but both of these are also going to this one. So many are going to many. So it's many to many. And finally, if you look at this collection of points down here, you'll notice that minus 2 goes to 2, but 2 also goes to 2. And 5 goes to minus root 19, and 5 also goes to root 19, but minus 5 goes to minus root 19. So clearly it's many to many. Now, talking about functions, functions can be even or they can be odd. And the definition of an even function is where function of minus x is equal to function of x. As a graph, it's like reflected in the y-axis. So, for example, if function of x is 1 plus x squared, if you put function of minus x, that'll be 1 on 1 plus minus of x all squared. Now, we know when you square a negative number, it's the same as squaring the positive. So that's 1 on 1 plus x squared, which is just the same as f of x. So if you can substitute in minus x into the function and work it through and end up with the same as f of x, you've got yourself an even function. An odd function is where f of minus x is equal to minus f of x. Now, this function that's been chosen here looks something like, if I draw it up, it looks something, it's going to approach from there, it's going to go like that. So you can see you can spin that one around 180 degrees about the origin and it'll land on itself. That's one way graphically to see if something is an odd function. But also you check where the function of minus x is the opposite of function of x. That is, look at this here. See, this is out at x. That distance down there is going downwards, a certain size, you know, maybe it's 5, and it's going down 5, right, so negative 5. If you go out to the same distance this side to minus x, it's the same height, but going upwards. So these two values are equal, but opposite. Well, then it's, if that always happens for your function, then it's an odd function. So you can prove that this is an odd function simply by starting with f of x and putting minus x in it. So that's minus 5 times minus x on 1 plus minus x squared, which is equal to 5x on 1 plus x squared, which is, see, the difference between f of x and what I get here is that they're just the negative of each other. So it's negative f of x. So I've sort of proven that it's a odd function. Whereas this one up here, if you were to draw a picture of it, it would look something like that, vaguely. And you can see it folds over on the y-axis. And you can see that if you go out to x, you go up that high. And if you go out to minus x, you go up exactly the same. It's not the opposite direction or anything. So for an even function, f of minus x actually equals f of x. They've got the same y values. Now, an odd function times an odd function is equal to an even function. So one way to help you remember that is to just get something like x cubed times x to the 5, just simple ones, but we know from the index laws that's x to the 8, which is even. Odd times odd is even. So you can pick easy ways to remember that sort of information. What about if you pick something a little bit more complicated, like sine x, and the one we had before, but let's just make it minus x on 1 plus x squared, that's what we had before. So if you have sine x timesing with that, it's an odd times an odd. So that is, whatever that is, that's going to give you an even function. And even times an even will give you an even function. And one way to remember that is to just pick an even like x squared and times it by another even like x to the 4, and that's x to the 6, which is an even function. So I could take more complicated ones like cos x and multiply it by 1 on 1 plus x squared, and that I know will be an even function. But if you take an even times an odd, or an odd times an even, so different ones, you're going to end up odd. So if they're the same, odd times odd, or even times even, you get even. But if they're different, odd times even, or even times odd, then you get odd. So you can see that because you can just pick to test, like say, x cubed times x squared, and that'll be x to the 5. So it reminds you that it would be an odd function. So something like inverse tan of x is odd, and inverse tan of x times by x squared, that's going to be an odd function. Now, why is it useful to know this? Because you might be faced with a question like this. What's the integral from minus 3 to 3 of x squared e to the x minus x squared e to the minus x? So it might look a reasonably complicated thing to have to integrate. But if it goes from the same number but negative to positive, like numerically symmetrically about the y-axis, you need to have your suspicions up that there could be to do with it being odd or even. So I'm going to check if I've got myself an odd or an even function. And what I need to do is just go, well, this is the same as the integral from minus 3 to 3 of x squared into e to the x minus e to the minus x. So that's the integral from minus 3 to 3 of an even function times an odd function. How did I know that was an odd function? This one here. Because if I replace minus x into there, that'll be minus x, and that'll be plus x. So it'll be e to the minus x minus e to the x, which will be the minus of what's written there. So I could easily see that it was an odd function. But even times odd is odd, which means that the integral will be 0 as long as you're going from negative something to positive something. It's the same absolute value. The answer will be 0. So you can work out what that integral is quite easily by that method. Or you might get something like this question here, where they tell you that the integral from 0 to 2 of this thing is this value, but you've got to find the integral from minus 2 to 2. Well, your suspicions are either it's even and we will have to double this, or it's odd and the answer is 0. So you just have to check if it's even or odd. Well, we've got ourselves an odd function here because f of x minus x is the same as minus f of x. And we've got ourselves, for sine x, we've got ourselves an odd function as well. And an odd function times an odd function is an even function. So it's the integral from minus 2 to 2 of some even function, right? Which means it's symmetrical, so it'll be double whatever the left is or double whatever the right of the y-axis is. So it'll be double the integral from 0 to 2 of x sine x dx. Now they've told us what that value is, so our answer will just be double that. It'll be 2 sine of 2 radians minus 4 cos of 2 radians.